All right, let's look at example 1, where we're just looking at the domain of f and g. And you'll notice that, as mentioned in the slide, I mentioned that the domain of sum, difference, and product are all identical, and quotient is very similar to that. So when we determine f plus g, the domain of f plus g of f plus g and f minus g and f times g, it's all going to be the same thing. So, and then we'll also determine the domain of f divide g. Okay, so to do this, we will look at the domain of f. That's what this is saying right here, the domain of f, and the domain of g individually. And then after that, we'll take the intersection of those two domains. So let's look at domain of f. Let's move this over a little bit. Let's bring this down over here. Domain of f. Okay, so looking at the domain of f, df, that's also known as df. df is defined as, well, we're looking at the square root of x minus 1. And we know that we cannot take the square root of a negative number. So we need to make sure, so what you do, the process of finding the domain of the square root of x minus 1 would be set what's under the square root, known as the radicand, set the radicand, x minus 1, greater than or equal to 0, because we cannot take the square root of a negative number, so we just need to set it greater than or equal to 0, we won't have a negative number. So we solve this, and we get x is greater than or equal to 1. So there's the domain of f. X is greater than or equal to 1. Okay, and now let's look at the domain of g. Okay, the domain of g, we have x squared minus 4. This is a polynomial, a quadratic, to be more specific. And we know that the domain of a quadratic function, or any polynomial, is all real numbers. So the domain of g is all real numbers. So the domain, this is d of g right here. So the domain of f intersect domain of g is is where they both are occurring. So notice that's what intersect is telling us, is where they're both located. So the domain of f is greater than or equal to 0. The domain of g is all real numbers. So where are they both located? Well, we know that that if we said all real numbers, then we're not including the entire domain of f, because the domain of f does not include all real numbers. It's just greater than or equal to 1. But x is greater than or equal to 1 is also contained in all real numbers. So they're both occurring at x is greater than or equal to 1, but nowhere else. So the domain would be x is greater than or equal to 1, and the way to write this in interval notation would be from 1 to infinity. Goes from 1 up, including 1, so 1 up to infinity. So that is the domain of f plus g, f minus g, f times g. 1 to infinity. And now, if we wanted to find the domain of f divided by g, we also have to look at where g of x is not equal to 0. So we need to solve that. Let's look at where it's equal to 0. So 0 is equal to, and we're going to say x squared minus 4. And if we solve this, and we want it to not equal 0, so notice that this is equal to x plus 2 x minus 2. We can factor that to x plus 2, x minus 2. So we know from this that x plus 2 times x minus 2 is not equal to 0. So that means x cannot equal 2 and negative 2. So we have to take that out of our domain. So so considering what we've already determined, we also have to take out positive 2 and negative 2. So notice that negative 2 is already not in this domain. So we don't have to worry about that. It's just 2. So 2 is in this domain right here, this interval. So we have to jump over 2. We have to go from 1 up to 2, but not including 2, and then go from 2 to infinity. So the domain of f divided by g would be from 1, not up to infinity, but up to 2, and then we have to jump over that, and then jump back on at 2, on the other side of 2, and then go up to infinity. So we're just taking 2 out of this interval, and that's what it's saying. This is our domain, but we have to consider this and take any values that will give us this, and that's what we've done. All right, so let me know if that makes sense, and if you have any concerns, please reach out to me if you have any concerns, and I'll be more than happy to help.